just talking about final position. So final position is initial position plus displacement. My initial position, I'm told, is -2. And then my displacement is just the integral of the velocity on this interval from 0 to 3. So this is a pretty easy antiderivative to do by hand. So it is t cubed minus 4t. Plug in 3, 0. So we would end up with -2 plus 15 minus 0 is 13. You okay with that one? Alright. Then, did you guys get a chance to finish that problem on the notes? I guess before we talk about that, I should also talk about Albert. Did everybody sign up for Albert? You alright there?
What's Albert? That's not mine, and I already told them not to. Is there an app for that?
I actually don't think there's an app.
I decided to Google, and then did you email us? I clicked on the last link you sent me, and it wasn't. Yeah.
Yes, there should. It actually should have come through like a week ago in your email.
I did not go to the email. I was on.
So, if you don't see an email from me it's probably more than a week ago now, okay, to sign up for Albert, I can resend the email. Okay, but this is how we're going to do our AP practices from now on. We're going to do them on Albert instead of on paper. And so this lets you know immediately whether you're getting them right or, well, I guess not immediately, because I said it to not give you the answers until you finish the assignment.
It like won't let me. Whenever I like ask to join your class or whatever, it's just like.
Oh yeah, I did block you from joining the class.
Good. No, but like I click on your link and then it will take me to my Albert, but it just says that like I have AP English on it. Yeah, it doesn't. But it won't say like
yeah, I like the.
So you just give us your code.
I
You can do that.
I log you.
So now I have both AP government. Where do people find all these different? There's so many. So we have to do Albert's on MathSL and FO.
Yeah.
Oh wait, no, you couldn't just like pick one to like make practice on.
It says a minute now, but I don't think I got. My student, I just logged out.
I hope you can answer that.
Enter your age.
If you need the code, here's the code. Yes, I can zoom in a little bit more. Tis of thee.
Sure, you should lie about it too.
Yeah. I think this
Is that an O or a Q?
0, O, 0.
What school do I put?
What?
It's not coming up. So, over the front.
That's how I want to do it.
You Friday. Like if I start it, can I stop it?
Yeah.
Whose airdrop is Kate? I don't even think.
Just makes me sad. Airdrop.
Kate's hawk slog. I was gonna like save this page to my home screen. And like the airdrop stuff comes off and someone is Kate's hawk slog.
everybody get in?
Me?
I know you.
Yeah, I'm not kidding. We were at BPA, and what the? We were at BPA, and I was like airdropping because there was this kid that had an orange. Like everybody was like dressed up because it's like supposed to be business professional. Everyone's like wearing suits, and this kid walks in like a t-shirt and like athletic shorts, and it's like throwing around this orange. And so like I wrote a note and I said, "Someone tell the kid with the orange to shut up because he's being super loud." And then I was just airdropping it to random people, see if someone would do it. I see one, it's like Chris, and I was like, okay, I'm sending it to that one. It's Burger. And he's sitting behind me, he's like, Big Mama, oh no. He's like, decline. So I keep airdropping him stuff, sitting in front of him. And then finally I airdropped him a picture of Dinah. He's like, Big Mama, it's Dinah.
Why airdrop?
I know, I got it.
The one I saw was pretty fun.
Didn't I take this picture?
Alright. Is everybody in?
I guess. I mean, I don't want to use it. I have no other option.
Right, you have no other option.
I do have the option to do it before, so.
No, it's not an option. Alright. So, challenge accepted. Alright. So,
Do what?
get out the notes from yesterday. We left off on this problem here. Okay, we found the intersection of the two curves, and then we had set up our integral. And if you read the reminder that I sent you, I asked you to try to finish that problem. Maybe not all of you read it, but
I did.
if you did try to finish that problem, what did you get?
-12.
Well, area between two curves is going to be positive, always.
See.
Well,
See, this is also not multiple choice.
thanks for playing.
Nick, what should I ask? Was it
No,
no?
I was like, it has to be Sharon.
Moving on.
I mean, you got the right number. Like,
Really?
yeah, but then your unit.
Wait, I forget, what was like the question? Like, what was it asking?
It was find the derivative of the rate function.
What was like the scenario?
It was you got gravel being processed at a plant, and it was the rate was tons of gravel per hour, and you were asked to take the derivative of that. So the rate of the derivative would be tons per hour per hour, but it was not plants.
I was thinking about Wyoming all the time.
You really don't understand how mad I was. I was like, please
I know.
help me.
I wouldn't tell her who did. I told her that somebody put plants as the unit, and I wouldn't tell her who it was. She
And I
was
guess I was
super
like,
mad.
had she been, it's either Sharon or me.
I know, she showed me this.
And I said, I guess it was me. I don't remember. I did that problem at like 11 o'clock at night before I left Wyoming. Did you take points off because I did six?
Well, I mean, 1 point was the correct unit. So,
No.
I mean, yeah. Yeah, she left it in here.
I took the ball again.
I mean, at least I didn't fail it. I got 67%.
Yeah.
Wait, I got into right on the center response. That's
Wait, how did we do that? How did you get in? I didn't. How did they get in? It was like, you do it?
Oh, I realized what I did. It says the plant processes gravel. So I was just trying to look for a unit because that's the last thing I put, so I put plant. So that was the word I saw up there.
I got plant and not plants. It was just plant.
The S is like the exclamation point, it looks like. I don't know, I'm just stupid. That's the answer.
I would have
Yeah, on that one. I don't, honestly, this was the one I felt I knew how to do. This one, I was this one. And I got, you know.
Oh god, I knew it. Look, I'm not sure if you this.
Are we having test corrections?
Yeah, we can do test corrections on this.
So I can change it to say,
Why is there
7 per hour?
It would be fine if there wasn't weird red thing on it. What?
So how did I get C?
I'm not surprised. Look.
So,
What's my grade in here?
4. Maybe like a 7.
I didn't look at it because
But technically, you did say if I float this entire semester.
Ew,
I mean, there's an airdrop.
you would say
I'm sorry,
that.
that's so gross.
Huh?
I airdropped it.
Is it the snowball one?
Yeah.
I want to airdrop that one. What if I still have 0 in every single one of my classes? Oh, no, no, wait, if I pick one of you, do you think I'll get his airdrop?
He has to be right. So then I can send him this.
Tyler makes that. This is work with Patrick.
All right. So if we were to do this problem by hand, okay, we said we had to split this up into 2 separate integrals, right? Because the top curve changes, right? So on this interval from -3 to 0, the quadratic is above the cubic. So I had to do the quadratic minus the cubic and then vice versa on the second integral. So if we do this process by hand, okay, and we're just practicing this by hand, we could put this in the calculator, but this would be fair game on either the calculator or non-calculator portion of the AP test. If we do this by hand, we end up getting the first area from -3 to 0 is 40.5, and the second area actually also is 40.5. That's just a coincidence that those work out to be exactly the same. That will definitely not always happen. Okay, but if we do work this out by hand, we get that the total area in between those curves is 81. Right? Now, not 12 or -12. Now, yeah, sure. If we do get a negative number here, we did something wrong, right? Odds are that all we did was flip our functions or potentially flip our bounds, right? So if we got negative 40.5, usually, I mean not always, we could have made some other mistake somewhere, but usually we can just make that positive, okay? Because usually the error was just we had our functions in the wrong order, or maybe the bounds in the wrong order, right? So if we get a negative number, we can just make that positive, because the area between 2 curves will always be positive, right? So let's do one more example together. This next example is just find the area between one section of the sine and cosine curves, right? So let's take a look at this region right here. Okay, we want to find the area of this region. So, and as we're going, as we're going, let's list out the steps that we're using over here. Sometimes we'll be given a picture, sometimes we won't. Right? So we need to be able to do these steps without a picture as well, or without the graph. A couple of these steps are really easy to do if we have the graph. Okay? Some of them require a little bit more work if we don't have the graph. So first, I'm actually going to do these backwards here. We're going to do B first. So, what's it? I'm flipping A and B. So it's backwards.
There's also C.
It's just these two. Doing these two backwards. So B, the first thing I want to do is find the bounds. The bounds are where the functions are equal. Right? So sometimes that's given to us. Sometimes that is not given to us. Okay? If it's given to us, step one's obviously pretty easy. But if it's not, what we want to do is set the functions equal and solve. So here, if my functions are sine and cosine, I want to set those equal, figure out where sine equals cosine. So, I mean, the easiest way to do this is to just think about the unit circle. Where on the unit circle are the sine and cosine values the same?
Oh.
Right, at 45 degrees, or pi over 2, which the values are both radical 2 over 2. There is one other place where that happens as well. Right, so we've got here at 45 degrees, or pi over 4. Yeah, right here. And on the exact opposite side, where we have both values are negative square root of 2 over 2. So generally, we want to think about radians instead of degrees. So we would use pi over 4 and 5 pi over 4. Okay. So those are my bounds. Okay. My bounds will be pi over 4 and 5 pi over 4. Those are where the functions are equal, and that would be these x values. Right? This is pi over 4, and then this is 5 pi over 4. So now the second thing we want to do, and again, if we have a picture, if we have a graph, step 2 is also super easy. But if we don't have a picture, we would have to do something here. We want to figure out which function is greater on this interval. So if we have a graph, that should be pretty easy to do. And so which of these functions is which? Which one's sine and which one's cosine? Do we know the parent functions for sine and cosine here? What those look like? Yes, but they start in a different spot.
The one that starts at I was just
Cosine's the one that starts at 1. Sine's the one that starts at 0. Right? But if we don't have a graph, what might be a way that we could determine easily which one's greater on this interval? Any ideas? Pick a value on that interval, plug it into both functions, and see which one's greater. Right? So my interval here we determined was pi over 4 to 5 pi over 4. Well, pi seems like it would be an easy value to choose in between those to plug into both functions. Right? So if I plug pi into sine, what's sine of pi? 0. And what's cosine of pi? -1. So on this interval, sine is greater than cosine. Right? So that's in part A here. We're saying that f of x is greater than g of x when we're writing our interval. So I would say sine is greater than cosine, just on this interval, right? Obviously, that's not always true, but that's true of this interval that we care about, from pi over 4 to 5 pi over 4. Then, step 3 is to set up our integral. So our integral is just this, our bounds, and then our top function minus our bottom function. So here, we would say our integral is pi over 4 to 5 pi over 4 of sine minus cosine. Don't forget your dx. Okay, so we could do this by hand, and it shouldn't be that difficult to do by hand, but let's practice using the calculator on this one. Math 9. 8's the derivative, 9's the integral. Are you in degree mode or radian mode? Make sure you're in radian mode. I think that Miss Graham borrows these to use for geometry, so I think they change it to degree mode. 2.828. Alright, we feel okay with that one? Alright. Let's I think we have time to do that. So I gave you a sheet that says area between curves homework. Okay, I do want to do another, the last example on the note sheet here together, but first on the homework, okay, I want you guys to try number 1 here. Okay, so go through these steps, right? On these, you're not given a picture, right? So we need to go through all 3 of these steps. Find the bounds by setting the 2 functions equal to each other. Then determine which function is greater on this interval, and then set up and evaluate the integral. So try number 1.
sketching it? Like, does it have to be like?
No.
Well, obviously it can't.
I mean, no, just so you can kind of understand what's happening here. Kind of see what this region would look like.
What if, like, at one value, you have to transfer it?
On an interval, since we found these 2 points of intersection, there's no possible way that it would change again, right? If those are the only 2 places where it intersects, one function is going to be greater than the other one on that entire interval. It could, yeah.
My face is.
Too late. I guess that's true. Yeah, you can plug it into the calculator.
So are we always gonna
What's that? Okay, so we found that they intersect at 0 and 4. So I'm going to pick a value in between 0 and 4 and plug it into both of them. So say 1. If I plug 1 in, I get 1. If I plug 1 in here, I get 4. So this one's great. So just do 4x minus x squared. Right, the greater one goes first. So we have 32/3.
wait, is the AP practice like not AP practice? AP test one in decimal form or fraction form? They not really.
On free response, they don't care. Unless, I mean, I've seen a few questions where it says give an exact answer, and in that case, like there's no way to give this as a decimal exactly, right? So we would have to write it as a fraction. So I mean, just pay attention to little things like that. But for the most part, if it doesn't say give an exact answer, they wouldn't care. All right, we okay with that one? Right, not too bad. Right. So on the notes, then there's one other situation that I want to look at here. Example 5. So here, I've got 2 functions written with respect to y. Okay, I've got x equals 3 minus y squared and x equals y plus 1. We can find the area between these 2 curves exactly the same way. Just with respect to y. So if I think about this region here, in between these two curves, if I wanted to try to find this the way we have been doing, well, I would kind of have to split this up into two pieces, right, because my upper curve changes, so I'd have to find this area and then find this area separately. So this would be a mess if I tried to do it with respect to x. So we can integrate with respect to y. Basically, all we're doing is turning sideways. Right? If you turn the paper sideways, it looks a little bit easier. So if I want to integrate with respect to y, well, what I'm going to do is find where these two curves intersect. I mean, they give us the bounds here. Right? They give us the bounds. Now, notice, whenever I'm integrating with respect to y, I'm going to use the y values as my bounds. I'm not going to use the x values. I'm going to use the y values. So, I mean, again, we're just kind of looking at this sideways and saying, well, I'm going from here to here. So my y values, and they tell us that. We don't, in this problem, we don't actually have to set these equal and solve. Right? They tell us that those y values are -2 to 1. So I know that my bounds are going to be -2 to 1. And again, in this problem, for number 2, determining which function is greater on this interval. Again, we can see this from the graph. Now, again, if we're thinking about looking at this sideways, greater means which one has the greater x value in this case. Right? Normally, we would think which one has the greater y value if we're anti-differentiating with respect to x. But here, we're saying, well, if I'm looking at it this way, my greater function is the quadratic. Right? So when I set up my integral, I'm going to say this function, so 3 minus y squared, minus the linear function, minus y plus 1. And now I'm using dy, since I'm integrating with respect to y. So if I wanted to do this by hand, I could combine like terms. Right? I've got 3 minus 1 as my like terms. So I could say this is the same as the integral from -2 to 1 of, what do we get, -y squared minus y plus 2 dy. And then we would treat this just like we have been. Right? We would find the antiderivative of each piece, plug in the bounds, and see what value we come up with. Okay, so I can integrate with respect to x, or I can integrate with respect to y. Okay? So go ahead and try this one. What do we get as an answer here? Yeah, for time's sake today, we can just plug this into the calculator. So, I mean, if you plug it into the calculator, you could just replace all these with x's. It doesn't really matter when you're plugging it into the calculator. Say what? 4.5. Yeah, I guess that could be it. Is that what everybody else got? Yeah. All right. Feel okay with that one? All right, now go back to the homework paper. Let's jump down to number 3. Let's look at this one.
I don't like to talk about her.
Oh,
There's not one.
Nicole's just being
Sorry.
I like dropped it and I got scared.
no, she is.
Make her switch it to a what's doing this.
Alright, so let's look at number 3 here on the homework paper. On this one, I've got x equals y squared and x minus y equals 2. Okay, whenever we're given something like this, we have the option of either writing both of these in terms of x or writing both in terms of y. Usually there's an easier way to go. So should we solve both of these equations for y or solve both for x? Which seems like it would be easier. Probably to solve for y. Or wait, did you mean, I'm sorry, did you mean get it in terms of x or get it in terms of y? Solve for x, solve for y? I don't know. Solve for x. Yeah. Yeah, so all we would have to do is add this y over, right? And this would become x equals y plus 2. So now I have both of my equations as x equals, and they're in terms of y. So now if we want to go through these 3 steps, we can do so by hand in this example. So first I would want to find the bounds. So I'm just setting y squared equal to y plus 2. So how would I solve this? Yeah, get everything on one side equal to 0. So y squared minus y minus 2 equals 0. Now what? Yeah, try to factor. So are there 2 numbers that multiply to negative 2 that add to negative 1? I think there are. Negative 2 and 1. So that means my bounds would be 2 and negative 1. So now step 2 is to determine which function is greater on this interval. So I need to choose a value between negative 1 and 2 and plug it into both functions. So remember, I'm choosing, this is a y value, right? So 0 would probably be a good choice here. So if I plug 0 in for y, I would get x equals 0, and then I would get x equals 2 here. All right, so the x equals y plus 2 is greater on this interval. So that would be my first function. So I'm going to say y plus 2 minus y squared dy. So what do we get for this one?
We have to roll it.
No, you don't have to draw it. .5? Is that what everybody else get? Questions on this process? Feel okay about it? Okay, especially if we change variables, right? We can either integrate with respect to x or with respect to y, depending on how the 2 equations are set up. Questions? All right, then. Let's see here. I don't think we need to do all of these. I would like to do more than one.
How about just finish the first off?
How about the evens?
could have just done the odds